we can do our work from the other day, but then we try to apply it towards one of these problems and we start to kind of lose focus a little bit. So I just want to make sure you can start this correctly in case I told you that we would do that together. I know some of you may have already started that piece, which is just fine, but please take out your graphing calculator and make sure you know how to produce this shape. Full 5 days this week, just 4 days next week. Martin Luther King Jr. Day on Monday.
No, that's not next week.
So you do not have school this following Monday. Staff will be here. We have some staff development stuff. But I will tell Mr. Dibble that Ava says that he is wrong.
Oh yeah, it is the 16th.
All right. Okay, so I'm just gonna type that in real quick to my calculator. Negative x squared plus 4x plus 7. And I'm going to make sure you need some paper, sir.
Yes.
Homework. Why don't you take this one? ZZ's name is on it, but you can just scratch it off. She doesn't take this class. And I'm going to press Zoom 6 for Zoom Standard, and there's my shape. And it looks like it crosses the x-axis just to the left of -1 and just to the right of 5. So you don't have to come up with a perfect drawing, but just a general drawing. So I want to help you get started a little bit, okay? I want to estimate the area. Interval from -1 to 5, 2 rectangles. Tell me, what the heck should I do? Okay, so Ella first says that she knows that the width of each rectangle is 3. So therefore, I'm going to have 3 times, and then I need to add up the heights. Agreed? So you don't have to draw this, but it might help you, especially for the bottom here. If the width is 3, what other number should I put in place here? 2. That way you can see that the width of this blue interval is 3, and that the width of the green interval is also 3. Okay? Now, are we doing right hand, left hand? We're doing all right hand stuff. So where do you evaluate the height of your first rectangle? You evaluate your height at 2. How will I evaluate the height at 2? You plug it into this function, right? So if you'd like to use your calculator, and yes, you do get to use your calculator on this test for certain portions. So if I do, I could go to my table, and I could type in 2. I could type in 5. And it looks like when I type in 2, I get 11. And then I evaluate the next height at 5. So we can all agree that by our drawing, this is a very crude estimation of the actual area, is it not? But it is an estimation. What should happen with our estimation when we push it to 12 triangles? It should get better, right? And so we have the height at 2 was 11, and the height at 5 was 2. So I have 11 plus 2 is 13 times 3 is 39. That is the approximate area. What I find people struggle with the most is this bottom part right there. Okay? So I'm going to let you take some time and work and ask some questions, and then we'll get into our next piece. But go ahead and start working and asking, and I'll be around. Go. Okay, here we are. Right-hand sum, left-hand sum, midpoint sums, trapezoidal sums. So far we just looked at right-hand sums. It was a nice introduction. Let us change that to some degree. What I want to do is I want to mark this spot right here as x sub 0. And I want to mark this spot as x sub n. Okay? So these are like the first x value at which we would be looking at the area and the last x value. Everybody okay there? All right. We'll say it's bounded above by the function f of x. And then what we'll have is we'll have the first spot, which is x sub 1. We'll have the second spot, which is x sub 2, so on and so forth. Can anybody tell me what the second to the last spot will be? X sub n minus 1. Good. Is that picture confusing to anybody? Which part? Do you see how I get the 0, the 1, the 2? X to the n. One less than that. So if this was, say, 10, that would be 9 then. Better there? Okay. So when we want to determine the approximate area, remember that our formula that we like to use is we take the width times the sum of the heights. Width times the sum of the heights. Everybody good? All right. Let's talk then again. How do we find the width?
Well, how many times can you split up?
How do we find the width of the entire interval? You take the last value and you subtract the first value, right? So we take the width, which is x sub n, minus x sub 0. Everybody okay with that? Then if you want to find the width of each rectangle, you would simply divide it by n, the number of rectangles that you've divided, right? So that whole b minus a over n, that's the same thing there. So again, we're doing right hand. So our first rectangle would be from x sub 0 to x sub 1. Where do you evaluate the height of your first rectangle? Do you evaluate it at x sub 0 or do you evaluate it at x sub 1? X sub 1. So you would take x sub 1 and type it in to the function. F of x sub 1 plus dot, 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 dot. What would be the last thing you would plug in as you evaluate your height?
F of x of n minus 1.
Yeah. So we go to the last rectangle, which is right here. You can see on the right-hand side, we have x sub n. Okay? So this one's the first spot you evaluate. This is the last spot that you evaluate. That's what we've been doing, agreed? So let's switch it. Let's do a left hand. Does the width of each rectangle change if I'm doing left hand? No, the width stays the same. We still have x sub n minus x sub 0 divided by n. Okay? What do we plug in to get our first height? As I look at this piece, if we're doing left hand, what do I plug in to get my first height? I start with x sub 0. Right? You start by plugging in this one instead of that one. You go to the left-hand side. So you start with f of x sub 0. Now let's go to our very last rectangle. Where will we evaluate the height for the last rectangle? Yeah, so you're going to stop with the x sub n minus 1. So, Easton, I believe that was a question that you had on Friday is, which one do you leave off or start with and so on and so forth. So that's the important element. Are we all okay there? Now, here's what's really cool is if you watch the geometry of this, suppose that I had a function like so, you don't need to draw this, boys. If we draw the right hand, is the right hand an over or underestimation? Over. Is the left hand an over or underestimation? If I were to average those two, is that a better approximation or a worse approximation? It is much better. And what shape does it make? A trapezoid. So the trapezoid is simply the average of the left and the right. So when we, and notice how nice that is geometrically as you see that. That is kind of pretty to look at, isn't it? So when you want to know the trapezoidal sum, very easy. All we do is we take your right hand sum, which we call R sub n, and we add it to the left hand sum, which is L sub n, and you divide it by 2. That will produce the trapezoidal. Now, trapezoidal does get a little trickier as we get towards the AP exam, but that's it.
Basically, you find a trapezoidal, so that's the problem.
Yep. Now, the midpoint, slightly more involved, but I think you guys will do just fine with it. Just try to keep up with the, the kind of the literature we have up here. My width stays the same, x sub n minus x sub 0 divided by n. And right after this, we'll practice an example, and it will hopefully become very clear to you. And what we want to do is we don't want to evaluate the height right now at x sub 0 or x sub 1. We want to evaluate it right between that. So let me show you geometrically what's going on so you can appreciate that. If I go simply back to an example that we just looked at, suppose I start there and I want to go to here, and we're going to just divide into 2 rectangles. So I have the red rectangle and the blue rectangle. And this time, I am not going to go to the right or to the left. I will determine the height at the middle. Tell me, is that an overestimation or an underestimation? Hard to tell, isn't it? I mean, notice the midpoint, it cuts off a little as an over, but then it undervalues this part, doesn't it? And if you look at, say, this example right here, as we draw the midpoint height, you see that I definitely have an overestimation here, but then a vast underestimation here, don't I? So the midpoint definitely does a good thing for us in trying to give you a little bit of both worlds. So here's what we do for that. We start with that, and we do the middle of these 2 spots. What is the middle of 82 and 92? Talk to your friends. What's the middle of 82 and 92? Talk to your friends. And stop. What's the middle? How do you get it? Okay, you looked at the difference, you divided and you added. Wouldn't it just as simple to take 82, add it to 92, and divide by 2? You just find the middle. Find the average. That's the middle. So that's what we do. Okay? To find the middle of x sub 0 and x sub 1, you add them together. So it's f of x sub 0 plus x sub 1, and we're going to divide that by 2. Now, I know that this looks confusing here. When we do an example, it's really going to come together, but we'll refer back to this. And then for the very last one, it's f of, and sure enough, it's x sub n minus 1 plus x sub n, all divided by 2 as well. That will find the middle. X sub n minus 1 plus x sub n, all divided by 2. Okay, let's try the basic example. It says use the following table to determine the approximate area bounded beneath the function over the interval -2 to 6. What do you think that this means right here? Right hand sum, 4 rectangles. 4 rectangles. Okay, talk to your peer. What's the width of each rectangle? Go. Five, four, three, two, one. What do you guys got? What's the width of each rectangle? 2. Why? Because you take the entire width, which is 8, and divide it by 4 to get 2. So we're going to take 2, and then we're going to multiply it by the sum of the heights. I'm going to draw out the regions, my intervals. I have a width of 2, width of 2, width of 2, and a width of 2. At what x value do you evaluate your first height? And you get 1 plus 7 plus 8 plus 6. Any question from somebody how I came up with those values? So important you know where all those numbers came from. Okay, let's add them up. I've got 15 plus 7 is 22 times 2 is 44. Right now, see if you and your partner can do L sub 4 on your own. Go. Okay, let's pause. Let's talk about it. Does the width of each rectangle change? No, it does not. But please look at where we start now. Okay, do we evaluate the height at 0 or do we evaluate the height at -2? At -2, when you plug that in, you get 5. Then you evaluate the height at 0 and you get 1. You evaluate the height at 2 and you get 7. You evaluate the height at 4 and you get 8. So notice how you pick up a new number at the beginning and you lose the other number at the end. That's what will happen when you transition between right hand and left hand. I add these up, I get 15, I get 21 times 2 is 42. Okay? Trapezoidal is easy. All we do is we take the left hand of 4 plus the right hand of 4 and we divide it by 2 and you get 43. That was easy. Yep. Now I need to do the midpoint. Now the midpoint, again, the width stays the same. It is 2. Where do you think I evaluate the height? The middle. You see it? And I want you to know that, please look up above, see how it says x sub 0 plus x sub 1 divided by 2, that tells you where to evaluate the height? Well, look, what's -2 plus 0? -2 divided by 2? -1. See how it fell in the middle? So we've got 10. Okay? 0 plus 2 is 2, divided by 2 is 1. So I evaluate it at 1 and I get 5. 2 plus 4 is 6, divided by 2 is 3, I get 16. And 4 plus 6 is 10, divided by 2 is 5, and I get 5. 15, 20, 36 times 2 is 72. So this is a weird behaving function, so 72 is definitely off compared to the others. Don't worry about it, but this is the correct result. Okay? All right, so we will pause there, and we will finish up the rest of the examples tomorrow. Tomorrow, please make sure that you have your calculator ready to go, because tomorrow we're going to do not 2, not 4, not 8, but we'll do 100 rectangles. But we have to have our calculator for help. And then, oh my gosh, on Wednesday we will add up the area of an infinite number of rectangles. And that is like one of the coolest days on the face of the earth. So it's going to be really neat.